Now see, next concept is specific heat capacity or specific heat. Suppose you have taken the substances of the different materials like of the masses m. If you are giving here, suppose the delta Q amount of heat to this body, there is a rise in temperature by delta T. So, when this much heat is given, delta Q heat is given to this body, rise in temperature by this delta T here. But if you change the material, you will find there is a different rise in temperature. Similarly, if you take many bodies or the many bodies of the different materials, you will find there is a different rise in temperature if the same amount of heat is given and mass is kept constant. It means rise in temperature depends on the nature of the material. So, we can write here this delta Q is directly proportional to delta T here, the change in temperature. Also that can be written directly proportional to mass. When this is combined, we can write is equal to ms delta T, where S is here proportionality constant. This S is known as specific heat of the substance. That depends on the nature of the material. We can write S is equal to delta Q upon m delta T. So, its unit can be written joule per kg and per degree Celsius or per Kelvin. If you are taking here, suppose in this formula only, you can define what is actually specific heat. So, if you have written this one, S is equal to delta Q upon m delta T, and if you are writing m is equal to 1, delta T is equal to also 1 degree Celsius or 1 Kelvin, then you can write delta Q is equal to S. It means specific heat of the substance is equal to the amount of heat required to raise the temperature of the body of the unit mass by 1 degree Celsius or by 1 Kelvin. But see here, the specific heat of the substance also depends on the state of the matter. Suppose if you are taking like a water, its specific heat is coming 1 calorie per gram degree Celsius. But if you are taking here suppose ice, for the ice it is coming here, it is here 0.5 calorie per gram degree Celsius. And if you are taking suppose steam or the gases, steam here, or that is called vapor also here, in that case you will be getting around 0.47 calorie per gram degree Celsius. So, a specific heat of the substance depends on the state of the matter. Now, see a molar specific heat. We have done just this formula here, Q is equal to given heat is equal to, this may be the heat given to the body, that means absorbed by the body, and also this the heat evolved by the body. So, we can write ms here, change in temperature by delta T. Now, see here we can write here S is equal to change in heat, or the given heat is equal to m into delta T, change in temperature. We know N is equal to m upon this capital M. N is the number of moles, m is the mass of the substance, and capital M is your molecular mass. So, we can write here m is equal to Nm. Now, we can write S is equal to delta Q divided by Nm delta T, and this is taken to this side here. So, Ms is equal to given by the capital C here, that is the symbol for molar specific heat, can be written 1 upon N here delta Q upon delta T. So, this C is called here molar specific heat. But see here, this C is molar specific heat. Here if you take N is equal to 1, delta T is equal to 1, then C will be equal to delta Q. That means the molar specific heat of the substance is defined as the amount of heat required to raise the temperature of 1 mole of the substance by 1 degree Celsius or 1 Kelvin.